Hello everybody, welcome back to another video. Today we'll be creating another end-to-end project on house price prediction model. So we'll be following our usual workflow. We'll be going on Kaggle, finding us a data set, and we'll be cleaning and training all the data values, and once we're happy with the result, we'll be creating a model out of it, and then we'll use the same model to then launch a front end where we'll be taking user inputs on what kind of house we're looking for and then predict the price of that house. So let's jump back on our screen and work on this project. Alright, so here we are on our screen, and if you look, we already have our Jupyter notebook created here. I'll explain you the directory structure in a bit, but let's quickly jump on Kaggle and look for a database that we can work upon. So I've already chosen the dataset, but I'll still ask you to explore it. So if you see my history, I already have a house price prediction dataset searched, and if you see from the list, we can't really find something that is good. If you look at the very first dataset and follow the link, you will find that it does not exist. So we'll try and apply some filters here. We'll go to datasets, look for house price predictions, and okay, so if you see here, you have house prices prediction on different areas or different parts of the world. So you see we have Paris house price prediction model, then we have this clean data set, we have a bunch of more data sets. So I would recommend you to have explore Kaggle and look for the data set that you think would work for you. I have seen the Paris house price prediction model, but the fields that are present in the dataset weren't really helpful in creating a model. But you can explore this model if you want. I have a few more models opened here. So the model that I went ahead with were somewhat. Give me a moment. So the model that I was trying to use in my training and in my data set basically here on the screen. So I personally used a prediction model from Seattle, Washington, and the data columns that were present in the data was something I was looking for and something I could use. I also have this model which is closer to home from Indian provinces. We have Bangalore's house price prediction model, and if you see, this is comparatively more familiar with how the Paris model works. It is around 276 KB, whereas the Bangalore one is 200 KBs of data set. So the data that's present here is useful. We have area type, we have availability of houses, we have location, size, society, not very important. We have square feet, could be important for area specific concerns. We have number of bathrooms, balconies present, and the price columns. And the model that I have, the dataset that I have used here, which is this one, has very common and usable fields. So I had bedrooms, number of bedrooms available in the property, bathrooms, the size of the property, the floor area of course, and we have more sizes. So the units are present, the IoT size is present, which is total area of the land where the property is based, and lastly we have zip codes and prices. So this is something which was a very simple data set. I thought I could get use of this, and it is very small. It is just 27 KBs. So the data sizes are small, possibilities of null values are less here. And let me warn you before I go ahead, because this model, when I have used this data set, I have got a very low accuracy level. So I've got approximately around 40s to 60s, somewhere around 50s to 60s percentile of accuracy. So I would recommend explore Kaggle as much as you can and go ahead with datasets which are heavier and which might give you more accuracy while training them. So okay, with all this done, I'll link you all three data sets in the description, so you can go ahead with whatever data you find more useful in your model building. So let's jump back to my notebook. Before we explore the code that we have written, this is the directory structure we'll be following. So train.csv is my main CSV file. My main data set exists here. This is something which you can look at later. So we're using model type of models. So I use Rich because that gave me the highest accuracy, which wasn't much, approximately 57% or 52%. Next we have our main file, which will launch our Flask app on the browser, and final dataset, which is what I have saved after cleaning it. So once I cleaned all my datasets, I created another CSV file just without any null values and stuff like that, our IPynb notebook, and we have a templates directory here which has index file inside it. So that is what will be launched on the browser. So we'll go through all of these files in the end. We'll first look at how we developed our model. So let us initiate. I simply imported pandas as PD numpy, which we'll be needing, and no rocket science. I simply first read the CSV file here. So train.csv, like I mentioned, is what my data set is named. So simply data equals PD read, and I'm reading my CSV file, and data.head will give you the top 5 values. So these are the columns you'll find inside the data set. You have number of bedrooms that are required, that are present in the property, number of bathrooms that are present, size and the size units. Then we have IoT, which is the property size, I assume, and IoT size units again. We have zip codes. Now mind you, these are not Indian zip codes, these are from Washington's. Some provinces has these zip codes. If you want zip codes that are familiar, you can go ahead with the Bangalore dataset and you will find zip codes that are closer home. Next we have the prices column, of course, the most important column we require. I next simply just typed in data shape. So we're looking at the shape of our data set. So you see we have 8 columns and we have 2016 rows. So that is the amount of data we have. Particularly a very small data set, so 2000 is not quite it is a workable data set, and which will be reduced after we clean the data set ahead. Next we have data.info. So I'm just taking out info of the data. You see the columns labeled as beds have integer values. We have float 64 in the baths column. We have float. Units have objects, of course. The units of both columns have object data type. We have float, integer, and float again. So these are the details, all the information out of the data set. Next, what I'm doing here, this is a small snippet where I am basically I'm extracting values of every column, every data present in a column. So if you see, if I scroll ahead here, we have the column of beds, the data type is integer, and the values, for example, if you see here 2.0, which is 2 bedrooms, so you will see there are 627 apartments that have 2 bedrooms. There are 493 apartments with 1 bedroom, and 282 apartments with 2.5 bedrooms. So likewise we have the data present for all columns. So if you see there are 12 apartments, or vice versa, I assume, every numeric value in the baths column is labeled here. The length is 897, the data type is present. Similarly, we are taking out square feet, we're looking at the sizes, then we have zip codes. So the zip code 7540 has 27 values, I'm assuming. So these are all the values that are present in particular columns. So couldn't help me much, but it was good that I could look deeply into the data set. And next I'm just looking at the null values here. So data is NA, which is null dot sum. So beds column entirely has no null values, bathrooms have no null values, sizes have none, units have none. The IoT, which has 347 values which are missing, so we have null values in these 2 columns, particularly in units column also we have same null values. Next, like I said, it is a very small data set, very simple data set, so accuracy might be low, but the chances of getting null values are near to none. So so simply to remove any errors we could get, I simply dropped the columns, both the columns, the sizes and the units. So after dropping, I described it again, the dataset, and once describing, you will see the count of beds is such, baths is such, and prices is such. We have mean, we have standard deviation, we have the third quartile, 50th percentile, and the maximum value. So 15 is the number of maximum beds we have, 9 is the maximum bathrooms we have in a property, and the size is so this is the size for the maximum apartment we have got. And okay, zip, maximum and zip won't help us much, and this is the maximum price we have got. Okay, so next we are just looking at the info again. We're checking out the non-null, we mostly have non-null values. Okay, now what I'm doing here is I'm looking at the counts again. So 3-bedroom apartments are 2-bedroom apartments are 560, and so on. Okay, I have a note here. We do not have columns with missing values anymore, so we don't need to replace. Right. So now that we have dropped the 2 columns, size and the size units, we do not have any columns that have null values. So we do not need to drop or clean the data much further ahead. But if you're using a different data set, you might have more null values. You might have ranges in some of the columns. For example, if you are taking size or any other column, probably size, let's assume size has ranges in columns. So there is a range from 250 square feet to 350 square feet. So you'll have to take a middle point out of it, or you have to separate those values in 2 different columns or something like that, or you'll have to take a middle point, I'm assuming. And with all that cleaning, you will then go ahead with the process we are doing here. Since this is a very simple model, we do not require much cleaning here. So again, I'm checking the head. Now we have 1, 2, 3, 4, 5, 6 columns right now. So 2 of them are omitted here. Okay, like I mentioned previously, since we are using a very small and simple data set, we didn't require much cleaning. We just had 2 columns that had a lot of null values, and we simply discarded them. But like I explained earlier, there might be cases of having range of numbers, or in this case we have a column called size underscore units, which just has the units of the size. So which either we have to merge this column, or even if we don't use it, we can assume it's a square feet value. So but then when you're using complex data sets, you'll have to take care that you clean the data properly. Now this is something that I have done, which is not needed in this data set, but if at all you're going ahead with a different data set, you might need to do this. This is a process where I'm finding prices per square feet. So for example, here we have an apartment with 3 bedrooms, 2.5 bathrooms, and a size of so and so, with zip code this. So the price for 2590 is 7,95,000. So this is the price for so and so square feet size. Now if at all we could find the price per square feet, we'll be able to find out the outliers in this data set. Now suppose you have a flat that has only 300 square feet of size, and the price is such, so it is not a feasible flat where some human being could live. So that is true, that is obviously an outlier. So we cannot have data like that in our data set, in our final data set at least. So this is a step that is important for a complicated or a larger data set, where I am getting the data, where I am creating a new column which is price per square feet, and this is the calculation for it. So the total price and the calculation, and this will give us a new column with the price per square feet. So you can see here, if I hit data and that column price per square feet, you will see the values right here. So these are the prices calculated per square feet of area of the house. Now if I describe this, you will see the new column is added here with the values, and these are all the required description of the data we require. You can go through these. Again, we have our max values, minimum values, and quartiles. Again, the shape hasn't changed. We still have 2016 rows and 7 columns. We have one increase column, which is the price per square feet, and if we hit on data, we'll get to see how the data placement is now. So these are the values right now in our data set. So again, like I mentioned, the size underscore unit is a column that we do not require. We can simply assume that it is a size in square feet, since we do not have any other unit present. That is the only unit we have throughout the column, so it can be omitted. And again, like I said, it is a simple data set, so price per square feet will be required in a complicated data set. Here, even if you omit it, it does not matter. So we are dropping both the columns here, and again I'm doing a data.head to see the new data set. So we have beds, bathrooms, size, zip code and price. These are all the columns we will require logically to find the price of a house, particularly with number of bedrooms, number of bathrooms, size and a zip code. Zip code working as a location form basically. Okay, so again we are just saving this data set, since I was happy with the simplification of the data I have made so far. If it was complicated, I might have required more steps to go here, but this looks fine, workable. So I am saving this as my final data set, data.to_csv, and naming the CSV file. So this is just saving the final data set, and if you look at the directory structure, you will find this file present over here. Okay, now let's move ahead. Once you are very happy with how the data set now looks like, the columns are pretty clean and usable, so we simply save our data set as a final dataset.csv file. And okay, so once your complications are removed, all the null values are removed, you are satisfied and clean with the dataset, you can now use this dataset and save it as your final dataset to use it ahead to train our model, and then use it in the front end basically. So I am saving it here. Now in the next step, what I am doing is, this is the process of training my model. So I am just creating two new, can't call it variables, but for the time's sake, let's call them variables. I'm dropping price, the price column from X, and then saving it into Y. Now what this will do is, I have all my features, all my parameters of things required for looking for a house, and then I have price into a different variable, so then we can predict. So in prediction, basically we'll give our parameters differently and the prediction differently. Okay, now I'm importing all the necessary things we need using the train test split, and we need 3 models, and I'm using 3 models. We are using linear regression, lasso and ridge. So linear regression couldn't give me much of an accuracy. Lasso and ridge gave me similar accuracy, around 50 percentile, which I wouldn't recommend going ahead with. Try using a more complicated or a more better data set than what I have used here, so you will get better accuracy. So these are the 3 models we are using. We are using one-hot encoder, we are using standard scalar, column transformer, pipeline and R2 score. So what I have done is train test split here, and I am printing the X train and Y train, and this is what, so remember we had 2016 values. These are now split into 1612 and 1612, and we have 4 columns in one of them, because एक column में सिर्फ price है, I suppose. Okay, now what we are doing is, we are applying linear regression, column transformation कर रहे हैं यहाँ पे with one-hot encoder, and I'm giving sparse as false, and then I'm applying it on beds. Now usually it doesn't make sense कि you're doing column transformation on beds, क्योंकि you need categorical values while doing this, but then beds is, as my assuming it is my super key column, I'm doing the column transformation on beds. So next I am applying scalar. I am doing linear regression here. I'll run these columns again, and you will understand, or I'll have to run the entire file again. I'll do a run all, so you will understand everything, because nowadays they give you a pipeline structure of how your data is getting tested, so you will understand it better. So right now, so far what we can tell is we are doing column. We are using one hot encoder and giving sparse as false. We're using scalar. We're using linear regression, and with that we'll kind of. Okay, we're using sklearn again to import linear regression because we couldn't import it earlier on. I suppose there was some issues with it. So linear regression, we use it here, and we then scaled and saw if the model could now be used with a linear regression. Okay, this is just a snippet to fix the technical error I got. Okay, next we are using pipeline. So pipeline mein what will happen is it will go to the column transformer, put this data into scalar, then put it into linear regression, and finally give us out the output of it. And we are using just pipe fit, xtrain and ytrain, and predicting the price that we got from this training, and we're checking the score here. So let all the columns run first, and we'll look for the result here. Okay, I'm assuming everything has run. I'll do it manually once again. Okay, so in linear regression, we're back to our section. Alright, so now that we have all our columns and all our cells running, this snippet basically just ensured that the linear regression was taking place. And here we ran our pipeline, and the pipeline here you will see sparse default value. Okay, we can ignore this warning so far. Alright, so the pipeline structure basically tells you how the value will go into one hot encoder and will pass through into standard scalar and then into linear regression, and then will give us the output here. So if you go ahead and check the score, like I said, we got around 57% accuracy with linear regression, and we did the same. We used lasso ahead, we used pipeline, and we got a score of 57% again. Okay, so linear regression, lasso gave similar. Here also we used same pipeline. We used one hot encoder, passed it through standard scalar, and we used lasso here. Then we went into the ridge model, used standard scalar, passed it through ridge, and we got 57.4688. So I assume 4688 was the highest accuracy we have got. So almost every model gave us an accuracy of around 57 percentile, just that a little difference was found in ridge, so I preferred saving my model with ridge. But then of course, if I used a different data set, I would have tried and made sure that we at least cross 85 to 90% of accuracy when you are working with this. So right now, just for the purpose of showing how we go ahead with this model, I am just printing no regularization. And okay, so we are basically checking out whatever accuracy every model gave us. So with linear regression, no regularization, we got 57.28152. With lasso we got 57.4681, and with ridge we got 57.4688. So these were the accuracy we got with using 3 different models. And now, depending upon your data set and accuracy that the model gave you, go ahead with the best model that you could find, and then save the model so we can go ahead with our front end part. So I'm importing pickle, and using pickle dump I'm just saving the model as ridge model.pkl with right binary. So this is mostly it in our notebook. Okay, so that is all to conclude this entire part of the notebook section. We literally we just cleaned all the data sets. We removed the columns that we found were not necessary, and yes, after all the cleaning, manipulation of the data, and saving our final data set, and then creating a model with with applying 3 different models, we found out we could save it using ridge. Just another suggestion is using your good data set that gives you better accuracy than this. And okay, this is just a big error that we got because the column size units are already removed from the data set, so they do not exist they do not exist in the current data set, and this is just the sparse having a new version of it, so these errors can be ignored. So this is all in the notebook part. If you go ahead in the directory structure, you will find that now we have our main notebook file here with our final dataset saved, and we have our reg model saved here, and these directories templates the main.py, and this is our existing CSV file dataset. So these two are new files that I'll explain you just right away. So we'll be opening VS Code and we'll be creating these changes in VS Code. Okay, we're on our Visual Studio Codes window, and I have opened the folder, opened the directory where the entire project files are present. So we have, so like you see, the templates folder basically has index.html file. This is what will launch on the browser from main.py. So we'll be running main.py, and using Flask will launch our index file on the browser. So before I even go ahead and explain you the code, the main.py final dataset was just there for reference. And okay, so with before even I explain you this code, I'll just simply show you the output of how this is supposed to work. So we'll go ahead and we'll hit Python main.py, and this will launch our Flask app on the browser. So it is present on the port 5000, like I have mentioned it here. So we are launching it on port 5000, and if you follow this link, simply give me a moment. Yes, so if you follow this link, it will redirect you to the browser, and this is where you will see everything present. So house price prediction model, if you enter the number of bedrooms you need, let us say you need an apartment with 2 bedrooms with 2 bathrooms and a size of let us say approximately 780 square feet, which is quite less actually. If you need an apartment with 1350 square feet and a zip code of XYZ, we'll predict the price and we'll get this as our predicted price. So we are fetching this from our trained model and the final CSV file. But if you look up these values, since I probably have the file open. Okay, so this is the main data set that we used, and if you compare these values that we have and then try to predict the price yourself, you will find there's quite a noticeable difference. It isn't that accurate, since I already mentioned we have a very simple data set, and that model gave us just 57% accuracy. So this is what the result will be shown. I hope you understand the working so far, and now let us go ahead and I'll explain you how the main.py file works and how the index file works. Alright, with all that being understood and we have seen how the output should work, let us go ahead and get an explanation of how exactly the main file and the index file works. Index is pretty simple. This is the entire front end of how it should look on the browser when the user has to input values. Now let us go ahead with the most important file here, the main.py file. This is simply the use of Flask on rendering everything, rendering the template on the browser. So we're using Flask. So from Flask we are importing Flask. We are using render template, request and JSONify, and we're importing pandas and pickle, important for us in the future. And this is just a boilerplate code of starting the Flask app. So we are using app equals to Flask underscore name underscore. Next, we are reading our data set. So data read, just like we did in our notebook as well. We are reading CSV file. Then we are loading our pre-made model, which is reg model, and I believe your model should be saved in the same directory, and so that it could locate it easily over here. Next, once we have read our CSV file, once we have loaded our model, we will go ahead and create a route for the index to load. So we are creating app route define index, and this will basically load our index page once we call our Flask on the browser on so and so port. So here we have, since we have input values as bedrooms, bathroom sizes, size of the house and the zip code, so we'll use this bedrooms equals sorted. We'll put this criteria in a sorted value, and we are taking these column inputs from our final data set that we have saved. That's why I have it open over here. So if you open your final dataset CSV file, you will see that these are our column labels, which is beds, baths, size and zip code and the price of cost. So going back, if you see here, these are the columns that we have defined and these are the placeholders of those columns. So this is what we are taking, and we are returning the render template index.html with bedrooms equals bedrooms, and this is basically fetching the data from our main file again. Now we have to create another app route for the predict button. So in order to predict, we need to again take in consideration of all the parameters from the columns, from the 4 columns, bedrooms, bathroom sizes and the zip codes, and we'll have to send a request to our main CSV file and our model, our main CSV file more specifically, and then get the parameters from it, so the user can then have an input there in the form. So we're requesting the data. So if you see on the browser, okay, so if you see or if you open it from here, so if you open it in the browser, you will see once you click on the drop down of this beds, you get the values from our main CSV file. So 1, 2 to 15 bedrooms, these are all the values present in our CSV file over here. So these are not defined in our index file. In fact, they are requested from our CSV file. Okay. Next, we are creating a data frame here, a simple pd.data frame for all the 4 columns, and we are fetching it again from the main file. Next, we are printing the input data. So if you see over here, whatever, so we just now we searched for 2 bedrooms, 2 bathrooms, size of 1350 square feet, and we got and this particular zip code. So this basically just gives you an input sanitization that you have entered this data and you're getting the value for it. This quite crucial for debugging if you're doing it. Okay. So next this is an entire snippet which is crucial if you're using a heavy data set. So for example, our final CSV file has mostly integer and float values. Suppose you have a data set that has categorical values. For example, you have a column named location. Like if you have a data set of a particular provinces, and that provinces has different locations, and that location column is in categorical data type. So in that case, you might have missing values in the column, and you cannot obviously omit that column. So if you have missing values here and there, you can use this snippet to basically have any unique or any unknown value that is present in the input field to fill it with something that is default. So this entire snippet does exactly that. It will replace it like you see in the comment, it will replace it with a default value present in the list. Okay. Next we have predicting the price. So this entire thing, what it does is once you hit the predict button, it will call back to the model and then give you the predicted price out of it. And simply we are returning prediction, and this is where, okay, this is a repetition of the code, apologies for that. And lastly, you simply just have to give your lastly you just have to end your Flask app, and you have to define what port you are trying to run it on, and that's all for the main.py code. And you can simply find it on your browser with localhost, and on port 5000 this will be running. So now hopefully if you are sorted with how the main.py file is working, we'll go ahead and we'll see how the index file is working. Alright, jumping back to our index.html file and trying to understand the working of this. इसको actually understand करना इतना difficult नहीं है, it is very simple. It is just taking the inputs from the file, sending it to the predict function in the main file, and then showing it on the browser, and mostly showing all the CSS that is displayed on the browser. Okay, so mostly कुछ नहीं है, the typical boilerplate structure of any HTML file. You have your title, doc type, and you have your CSS over here. So everything styling is mentioned here. यहाँ पे title, and you have the strip, right? So all that things end over here. Welcome to house price prediction model. And from here what we start is a form input field. So we have a form ID with the name prediction form. So here say we have a form that starts, and next is the footer, and I'll explain you the later part. So in form what we are doing is we have our labels, of course. We have our labels. So beds में हम पूछते हैं कि the number of bedrooms that the user want. यहीं पे अगर if I change it from beds to bedrooms and save it, so it will show us, it will ask the user the number of bedrooms that they require on the main page, which should actually be the case. It shouldn't be beds, it should be bedrooms over here, and यहाँ पे भी bathrooms. So तो अब तक you must have understand कि index is basically everything that you have to show it on the browser. तो यहाँ पे in the form field we are asking for the bedrooms. We are taking fetching it again from our main final file, and if you see we have this select number of bedrooms as our default entry in the form, and this is a function that we have applied because if you know the form function in HTML, it is basically based key. You take an input in the form field and then forward it to a particular URL or a path that the coder basically asks it to send to. But usually here we are restricting the form's usual working, and we are asking the form to basically fetch the bedroom data from the user. Fetch the data from the file and then send it to the predict button on the main.py file. So this is all that this code basically does is. And similarly we have labels and the structure for all the other input fields that we require. Okay, so I hope the form element and the entire how the structure of form is working is understood. If at all nahi samjha, kuch doubt hai, so this function is the only important part I could say in the form. Baki to it is everything which we already use in HTML. So this basically is called as, if I am not wrong, this is called a Jinja function. Jahan pe we start a loop, we end it right there. So this loop will do nothing but fetch your data from the final CSV file and send it to the main.py file, and in order to get a prediction out of it. So everything will be sent and stored, and then with comparison to the main file, it will be predicted with the help of the model, of course, and then that will be predicted on the browser. Okay, that is all that is important in the form element. After this we close our main. We have a footer here and we have fetch options. Of course, the script function basically helps you to fetch and append options from the main file to the browser input fields. We are using JSON here. That is why we imported JSON in the very first place. And okay, the script basically does exactly that what I have said right now. And okay, next we are fetching options from the drop down. So we are fetching the zip codes differently. We are fetching beds. So bedroom data is being fetched from the beds column. This is all that has been defined here. We are using JavaScript to send the data. Sending data where so we are taking input from the user, fetching it from the final data CSV file. We are sending it to this main files function, which does the prediction. So if you see here, we have a route, we have an app route for predict button, right? So this entire thing from the index file is so this entire send data function sends the data to this app route basically, and then with the help of this prediction you get your price displayed on the browser. Okay, yeah, and the price is displayed here in INR plus price, which is defined already, and the script will do exactly which is the most crucial function of our front end part. Okay, so this marks the end of the project. I hope the directory structure and everything is cleared so far. If you see, this is our project. I'll close this thing. Okay, so you will see we have your IPYNB checkpoints here, not important in the VS Code, but okay. Templates may we have our index file, we have final data set here, we have our house price prediction. Okay, this must be this is the notebook. We have our main file, we have our trained model and the actual data set. So yahan se nothing, the main file basically renders your Flask app and has a root that launches the index file to the browser. Okay, if I have to show you something logical that I have seen, so let's say we have, okay, I'll open this file for you. This is the main dataset file. Let us say we are targeting some property here. So we are targeting this property that has three, okay, is this seen here? So this has 3 bedrooms, 1.5 bathrooms, I'm assuming, 1280 square feet of area. These are the columns we omitted, and 98146 is the pin code for this. Okay, so let us try and input these details. So 3, 1.5, okay, so we need 3 bedrooms, we need 1.5 bath area, we need an area of 1280, right? 1280, yes. So an area of 1280. Okay, this is the square feet, and the zip code was 98146. 98146. So this is the property we have targeted, and looking at the data set, the price that we should get should be around 6,25,000. Okay, now I'll show you the magic. If you predict the price, you get a price that is, okay, this is still fine, this is closer to 6,25,000. It has approximately 5,89,000 something, so closer to 60,000 at max. So we are still lagging with the accuracy part here. Assuming we just have 57% accuracy, this is quite inappreciable in a way. You should aim on a much accurate model. So what I've tested previously was, I was testing for some property for around 6 lakh something of a price, and I got a prediction of 3 lakh something. So I was like, okay, now that defines why it is 57% accurate. So that is all from my end. The only point to suggest here is use a better dataset. We have 3 links in the description. Go ahead and explore with that dataset and different models if you want, of course. And yes, I hope the front end back end part was cleared and everything end to end. If you have any other doubt, write it in the comment section, and the team or me will try to answer it as soon as we can. Okay, thank you so much.